Hello and welcome. In this lecture, we are going to be learning about references, an alternative to pointers. And we're going to see why they're different, why we might want to use them. Let's dive in and see. So as well as pointers, there's a very similar related concept called a reference. Now, both pointers and references are essentially just a memory address. They both store a reference to where another variable can be found. And in this way, they are incredibly similar. The difference between the two comes to basically down to whether they can be reassigned. Basically, can they point to a different address after they've first been created? In the case of a pointer, that answer is yes. You can change a pointer to point to a new memory address, a new actor, a new component, whenever you like, as long as it has the right type. A reference, on the other hand, can only be set up once when you first create it to point to another variable. It can't then be changed again. And this is a safety feature because repointing variables can lead to problems where those variables might disappear or where you set that pointer to null. A null pointer is essentially a pointer that points to nothing, and trying to do stuff with a pointer that sets to nothing can actually crash your engine, which isn't an ideal result. With references, because you have to give them a value when you first create them, they can't be null, so you cannot get these null pointer crashes. So let's start to have a look at some of the syntax involved. So when you access content with a pointer, you have to use some special syntax. You have to put this star in front of the pointer to make sure you're getting the value in the pointer, not the memory address. With references, because you never really need to get hold of the memory address, you can just use the variable as if it was the variable it's pointing to. You don't have to use any special syntax. Now, there's accessing the address. So with pointers, you get hold of the address automatically when you use the variable. With a reference, you have to use special syntax to do that. You have to use the address of operator, and it will get you basically the same address as the original variable. And then there's changing the address. With a pointer, we've seen that you can assign the address and use the address of operator to do that. With references, this isn't allowed, so there's no syntax for it. And finally, what if we want to change the value that we're pointing to? Not the address, but the actual value being stored at that address. Well, with pointers, you got to, again, use some special syntax. You have to put that star and then assign something. So the actor pointer, you assign to the star actor pointer. With references, again, because you can't change the actual address, you don't need any extra syntax. We can drop the extra syntax and just have the actor reference equals actor, means that you are overwriting the value in the pointed to location. So that's all a bit theoretical. Let's have an actual example. So if we had a float that was perhaps storing the damage done to us in the game, and in that we are storing the current damage is set to 0. No one's done any damage to us. Now we might want to create a reference to this to, instead of copying it around, we might want to pass it into a function but without actually changing it. The way we can do this is to have a float and then put the ampersand after the float, and the ampersand says that this is a reference to a float. It is not a new float itself. It doesn't allocate any float memory, it just allocates pointer memory. And so we can call this the damage ref, and we can set it equal to damage. We don't have to take the address of or do anything like that. It automatically knows, well, this is a reference and this is a variable, so what you're trying to do here is set up a reference to that variable. And sure enough, if we go and ulog, then we can print this as if it were just a regular float. So we can say damage colon and then %f. And then here we can do just print damage ref. We don't need any special syntax. We can use it just like a regular variable. Let's go ahead and hit play after compiling, have a look at our output log, and sure enough, the damage is coming out at 0, which was the value that we set. But that doesn't necessarily prove that I haven't made a copy of that original variable. So I'd like to challenge you to try changing the value and see what happens. So use the reference to damage to set a new value, and then print out the original value too. So the original value next to the reference value, and have a look. Are they the same or are they different? You only changed the reference, but does it change the original as well? Because that would imply that they are both the same variable. Pause the video and have a go. Okay, welcome back. So let's give this a stab. So to change the reference now, we're going to do damage ref equals, and this time I'm going to say that we did 5 damage. And notice I haven't had to use any special syntax here. It's not repointing the reference because we've already declared it and set its reference up on that first line when it's created. We can't do it again, so now we can just be setting the value. So what I can do now is we've got the damage ref is in the log. Let's also put a damage and %f onto that same string and then pass the damage in here as well. And then we're going to compile and have a look. Let's hit play, go into our output log, and sure enough, it's printing out damage ref and damage as both having the new value that we've set, the value of 5. So in essence, what we've got here is 2 variables that point to the same piece of memory. You could almost say that they are the same variable, but with different names. So this has the benefit of not needing a copy, just like a pointer, but it also has a lot more benefits because it's so much easier to use. We don't need all that extra syntax, and it's also safer to use. So as long as we don't need to repoint anything, using references is generally preferable. Now let's do a quick review of some of the symbols we use here because they can get a little bit confusing. They're used a lot in C++. So the ampersand and the star symbols, let's have a look at them in context and what they mean. So when we are using them, in an expression, here are some code examples. You might see the star before a variable. You might see the ampersand before a variable. What does this mean? Well, with the star symbol, the syntax of putting it before the variable means we're getting the contents at actor pointer. Now, with the ampersand, if you put the ampersand in front of a variable or in front of a reference to a variable, it's saying that it's getting the address of that variable. It's getting the address of the actor or the address pointed to by the reference. Now, when we are declaring, when we're using it in the type of a variable, the stars and the ampersands have almost the opposite meanings. So the star means that this is a pointer to a U actor. And the ampersand means this is a reference to a U actor. So just remember this, that there is a completely different set of meanings whether you're using them with a variable in an expression or whether you're using them in the type declaring a variable. Now, I won't go into it in too much detail, but to add insult to injury, these can actually have other meanings in other contexts. That ampersand can mean a bitwise and. The star, as we've already seen, can be used with strings in the U log. So this isn't necessarily all of the meanings of these 2 symbols, but they are pretty much all the important meanings referring to pointers and references. Great stuff. So we've learned about pointers, references, how they relate to each other, how they are different, and why we might want to use them. I'll see you in the next lecture.